right, so because second period today did not get to this lesson, I wanted to videotape it. So this is third period, and they are going to say hi. Hi. Nicely done. Okay. Okay, so segment lengths in circles. We are basically coming up with two properties about how to deal with chord lengths in circles. Now, if you notice, the first thing I want to point out about these is if you look at these pictures, they look like the pictures where we were doing outside, inside, and on. But one of the reasons we put those problems in the first half of the unit, circles part 1, and these problems in the second half of the unit, because it's easy to get confused about that, and this is not like that because it's not angles. So this is different from outside, inside, and on because that was all about angles and degrees and arcs, and those things are all interrelated. These are all about segment lengths, okay? And basically what we're going to do is we're going to take everything above this line and say there's one rule for how we do all of these, and then there's another rule for how we do the ones below that. Okay, it says when two chords, and it's interesting, I think this might be, I don't know, British or something. Chords, there's no H. No, they spelled it right other places. When two chords, H, when two chords intersect on the interior of a circle. So it's still, the difference is still going to be where they intersect, whether they intersect inside the circle or outside the circle. That's still going to be the difference. But we're not thinking about it in terms of angles, though. We're just talking about segment lengths, chord lengths, segment lengths, secant lengths, tangent lengths. It's all segment lengths. But it still does matter. The difference is where do they intersect each other, inside the circle or outside the circle. So if they're inside the circle, each chord is divided into two segments. So in other words, they're saying, like, this whole chord has two parts, one part over here and one part on the other side of the chord it crosses. And this one too. The chord AB, it's kind of hard to read the letters, but that's A, that's B. Chord AB is divided into two parts, A to M and M to B. Okay? So if two chords with an H intersect on the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. That can be a little bit hard to wrap your head around what they're saying. So here's how we like to say it. We like to say basically part times part of one of the chords equals part times part of the other chord. So this is how I will say it to kind of help remember it. Now, all of these are all of one of chords, and these are all of the other chord. So it's not like I mix and match part of one chord and part of another chord. It's two parts of the same chord. So in other words, A, M, and MB get multiplied to each other. And then on this one, this says YMZ. So the chord is YZ. The two parts of chord YZ, YM and ZM, get multiplied times each other. So for example 1, the 10 is going to get multiplied by the what? The X, the other part of that same chord. So 10 times X equals what times what? 12 times 5. There you go. So 10 times X, I should have drawn my line a little bit lower. I'd like some space here, but I didn't. 10 times X equals 12 times 5. What's 12 times 5?
60.
60. So if 10X equals 60, let's go over here. X equals 6. Oh, can't see it very well. Sorry. All right, number 2. What does the 8 get multiplied by?
X.
So X, 8 times X, which is just 8X, equals, what does the 4 get multiplied by? 18. What's 4 times 18? 72 is correct. Then what?
Divide by 9.
By 9?
Not 9. 8. That's my bad.
X equals 9. All right, next one. 5 times 5 times 4 equals 2X. 5 times 4 is 20. So if 2X equals 20, what's X? 10. And last but not least, 4 times equals 2 times 4 times 3.5 is 14. 14 equals 2X. X equals 7. Ta-da! That's all you have to do for those. So these are chords that intersect in a circle, and these are the pieces of their lengths. All right, next relationship. Notice that they have two theorems here. One of them is if you have two secants, and the other one is if you have one secant and one tangent. Okay? I'm going to combine them into one rule. I'm going to just say there's one rule, because notice that the thing they have in common is both of them, the segments intersect outside the circle. That's what they have in common. So we're going to have one rule for inside. We already did it up here. We're going to have another rule for outside. Now the special case gets a little bit different, but I'll show you that when we get to it. So our rule for outside is going to be, where do I write it? I'm going to write it right here. That the outer part times the whole thing on one segment equals the outer part times the whole thing on the other segment. So write that down. So on this top, the outer part means EB is the whole thing. So the outer part of EB is just EA. So EA times EB. See that? EA times EB. And then the other segment that comes from E, the outer part is EC, and the whole thing is ED. Notice that the whole thing includes the outer part. So it's outer part plus inner part. Sometimes that will come up because you'll have to add with variables. On this example here, outer part for PR is just PQ. Whole thing is PR. So that's here. Now notice on the other one, the tangent segment, the outer part is the whole thing. When the outer part is the whole thing, that means it just gets multiplied times itself. Outer part is PS, whole thing is PS, so it's just PS times PS, which is PS squared. So that's the difference, is that for a tangent, you just have to remember that on one of them, the outer part will be the whole thing. And so you just multiply it times itself. All right, so for instance, on number 5 here, this segment up here, what is the outer part? 3. Now, here's the thing. I told you guys about this in the last unit. There is a temptation to call the whole length here 3x. It is not 3x. What is it?
X plus 3.
It's 3 plus x, or x plus 3. When you're doing two parts of a segment and putting them together for a whole length, you add them. Don't multiply. So this is not going to be times 3x. It's going to be times 3 plus x. So, or we're going to call it x plus 3. You have to distribute. This is the same as this. So on this side of my equation, I'm going to have 3x plus 9. On the other side, the outer part is 4. What's the whole thing? What's 7 plus 4? 11. Make sure you're adding again. You wouldn't multiply there, so you don't multiply on the other side. So that's 44. So that's 44. And now I can solve my equation. Subtract 9 from both sides. 3x equals 35. Is that right?
Yep.
Yuck. So that means it's not going to come out exactly. So I would probably just leave it like this. It's not going to come out as a whole number. That's what I meant by exactly. It is exactly. It's just not whole. Now I want you to notice that number 6, things are written a little differently. You have to notice when it's given to you differently. What's different? The whole thing is x. You don't do any adding to get the whole thing because they're telling me that the whole thing is x. So on that segment, outer part is 3, whole thing is x. And on the other segment, the outer part is 4, and the whole thing is
12.
12. Where'd you get 12?
Added 4 plus 8.
4 plus 8. You got it. So this gives me 48, and x is
16.
Good. All right, next. Let's go with the tiny segment first. It's a tangent segment. So what's the outer part of that segment? X. Well, okay. Y'all are jumping ahead. The outer part is x. The whole thing is x. And so that's why you just said
X squared.
x squared. Because it's the outer part times the whole thing is just going to be x squared. So x squared equals 3 times what?
27.
27. Not 24. Be careful to add it. So x squared equals 81. So what's x?
9.
Is this a case where it could be plus or minus 9?
Yes.
Well, actually,
No.
I'm going to go with well, actually, Dylan, because why? X represents a length.
Length can't be negative.
This tangent segment can't have a length of -9. So it has to be +9. That's why I didn't put plus or minus. All right, last but not least, tell me how to set this one up. Starting with the x.
X squared equals 4, 12. X squared equals...
I love hearing everybody in different places. Okay, so what's x going to equal?
8.
You are perfect. Ta-da! Good job. Say bye, everybody.
Adios.
Wait, I'm sorry. We have one question. What's the question?
Like on the example, it says like PQ times QR. Yeah.
Oh, gosh, that's terrible. They're wrong.
Okay.
So it's PQ times PR.
Yeah, this should say PR. Absolutely. Thank you. That was wrong. I promise. Okay, good catch. I'm glad we got it still on the video.